Hello everyone, this is T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this case study video, we are going to discuss about the case study on small sample student t-test. Introduction. What is t-test or t-distribution? To establish confidence interval at certain level of significance for the population mean with the standard deviation is unknown, and to find confident interval for population mean with the sample size is small, then we use t-distribution. It is discovered by William Coset under the nickname student. Hence, this test is called student t-test. Test of significance for small samples t-test, that is small sample test. Here we study the test of significance for small samples of size is less than 30. In all exact sample tests, we assume that the population from which the samples drawn are normal. The test of significance for small sample student t-test. Let x1, x2, x3, etc., xn be a random sample of size n from a normal population with a mean mu and a standard deviation sigma. The student's test is defined in the statistics as t is equal to x bar minus mu divided by s divided by root n. Here what is x bar? It is arithmetic mean, that is sum x by n. And standard deviation in this statistics is summation of x minus x bar the whole square by n minus 1. That is sum of square of deviation of mean from the data divided by number of data minus 1. Because we take n samples, one person is observed to all, therefore include that one, therefore the number of data is n minus 1. So what are the properties of students' t-distribution? The variable ranges from infinity to 0 or 0 to infinity, like normal distributions. It is asymmetrical distributions and its mean is 0. T-distribution has more deviation than standard normal distribution. The variance of the distribution is definitely greater than 1. What are the applications of t-distributions? To test the significance difference between sample mean and hypothetical, that is a population mean. And to test the significant difference between two samples means. Third one, to test the significance difference between observed sample correlations coefficients and sample regression coefficients. So now we go to the case study. The problem statement: 10 individuals are chosen at random from a normal population and their heights are found to be 63, 63, 66, 67, 68, 69, 70, 70, 71 and 71 inches. Test: if the sample belongs to the population whose mean height is 66, at 5% level degrees of freedom is 9 degrees of freedom is 2.62. Here what's the problem? Here there are 10 data, 10 persons, and we have the we take their heights in inches 63, 60 and so on up to 71 to test whether this population average height is 66. So here the number of data is 10. So 10 is less than 30, therefore we apply the small sample test or student t-test. So what are the test statistics? Is x bar minus mu divided by root of s square by n or s by root n. Okay, what is null hypothesis? Null hypothesis is nothing. The sample belongs to the population whose mean height is, that is mu is 66 inches. So the test hypothesis, from this test hypothesis, here we have the number of data is 10 and the average. What is average? Summation x divided by n. So we add all the heights in 10 inches is 678. So number of data is 10. Therefore, the average is 678 divided by 10, that is equal to 67.8. So now we find the standard deviations. Therefore, write all x value and its corresponding the square of deviation value. If 63 inches, the height is 63 inches, its corresponding square of deviation value is 23.04. Next 63, its deviation value is 23.4. 66 is 3.24. 67 square of deviation value is 0.04. 68 square of deviation value is 0.04. 69 1.44. 70 4.84, and again 70 4.84. 71 10.24, and height is 71. Its square of deviation value is 10.24. Sum of all the heights is 678, and the sum of square mean deviation is 81.6. Therefore, so the variance or the standard deviation is root of variance, or we take variance, that is s square is summation of x minus x bar the whole square by n minus 1. That is sum of square of deviation of mean from the data divided by number of data minus 1. So already we calculated the sum of square of deviation is 81.6. The number of data is 10. 10 minus 1 is 9. So after reduce that, we get 9.066. Therefore, so it is standard deviation. And it is a variance. And what is a t-test statistics? Is x bar minus mu divided by s by root n, or root of s square by n. So this average value is 67.8, already we calculated, and the observed value here it is 66 by root of variance is 9.066. Number of data is n. Surface is 1.8 divided by 0.95215. So after reduce we get 1.89. So it is table value. So it is calculated value. The calculated value is 1.89. The table value at 5% level of significance for 9 degrees of freedom is 2.62. Since this calculated value 1.86 is less than the table value 2.62, therefore we accept H0. So from this we conclude the sample has been drawn from the population whose mean height is 66. Thank you.